Section 4.5, prove triangles by angle, side angle, and angle, angle, side. Our goal today is to use two more methods to prove triangles are congruent. So our first method we have here is angle, side angle. So we need two pairs of angles congruent and the included side. So when we look at this, we can pick any pair of angles. So we'll pick these bottom two, for example. And for it to be angle, side angle, we need the side that is connecting the two angles to be congruent. This is angle, side angle. The other version we're looking at today is angle, angle, side. So this is two pairs of congruent angles. And instead of being the included side, we call it a consecutive side. And how this one works, if we have this same single double that we had before for angles, instead of being the side between them, which would be angle, side angle, we have the next side. So single, double, side, single, double, side. That is an example of angle, angle, side. Now, this one could also have gone, if I went double, single, we could have had this other side here. So there are a couple different options when working with angle, angle, side. You just have to make sure they're in the same order, because you cannot go single, double, side and go double, single, side. This is a no-go. That does not work. You need to have that consecutive side be in the same relative location. So we're given a proof here. So we're given that AB is perpendicular to BC. DE is perpendicular to EF. And that AC is congruent to DF. So we got AC is congruent to DF. And we also have that angle C is congruent to angle F. Alright. And all of this was given. As I look at the diagram here, I'm trying to prove the left triangle is congruent to the right triangle. I already noticed I have an angle and a side. Typically, when I see perpendicular, I'm thinking hypotenuse leg. But since I already have an angle, I switched my thinking from hypotenuse leg to going, maybe it's going to be angle, side angle, or angle, angle, side. And when looking at this, the side is not where the perpendiculars are, so it's going to be more so an angle, angle, side choice here. In order to use angle, angle, side, I have to show that the angles are, those right angles are congruent. So I have to go through that part. So we have here in our proof, we have a side and we have an angle. And now we need to prove this other angle is congruent. We look at AB as perpendicular to BC. We know that by the definition of perpendicular, those are right angles. So we are going to say this, angle ABC and angle DEF are right angles. And we know this by the definition of perpendicular. The thing of it is they're right angles. That's fine. We do not have in our proof that those two triangles are congruent. So we're looking for what is the link. Well, we know that all right angles are congruent. That was our right angles theorem. So we will take this next step in saying angle ABC is congruent to angle DEF, and our reason being right angles theorem Or you could say, if you can't remember the name, all right angles congruent. That is our reason why. This gives us our second, our second angle. So if I look at it now, I have two angles aside. I look at my diagrams here and I see that the side is not between the two angles. So I will say these triangles are congruent. So we have triangle ABC congruent to triangle DEF, and our reason being angle, angle, side. Biggest thing here is every time you see perpendicular does not mean it's going to be a right triangle proof. In this case, we had to prove that the right angles are congruent, and thus using angle, angle, side. You will notice that anytime you are given perpendicular, you are always going to have, say that they are right angles by the definition of perpendicular, and then that they're either congruent, if you're using it as an angle, or if you're using it for a right triangle, you'd say the triangles are right triangles. So you're always going to have these two steps whenever you're dealing with a given of that they're perpendicular. Our next proof, we are given that JL and KL are congruent. So JL and KL are congruent. And angle HJL is congruent to angle HKL. And if I mark these angles, HJL and HKL are right here. And I am trying to prove this triangle is congruent to this triangle. Alright, so if I look at JL and KL are actually sides on the triangle, so I have a side. But the angle HJL and HKL are not actually in my triangle. That doesn't really help us directly. But if I look at them, we have a theorem that talks about this situation. If I look closely, these two angles here and here form a linear pair. These two angles form a linear pair, so they're supplementary. And angles that are supplementary, the same angle, are congruent. So we will say that angle GJL is congruent to angle IKL. And this was the congruent supplements theorem. Angles supplementary to congruent angles are congruent. If you couldn't remember the name of it, you could always write what I have in parentheses here. And so we have those two angles are congruent. That gives us an angle. Alright, now I've gone through my givens, and I don't have enough to prove the triangle, so I need to look at the diagram. Is there anything else on this diagram that I could use to prove triangles are congruent? And when I look at these, I notice I have right here this pair of vertical angles. Now, when you're doing angles, you can do a single arc, a double arc, a triple. You can keep adding arcs. Another option you have is you can do a single arc with a line. Then you could do a double arc. You could keep using different symbols, you know, an arc and a hash combination, or a double arc with a single hash, or double arc with a double hash, or single arc with a double hash. You can use those combinations to mark more angles. So I'm going to draw a single arc with a single hash here for my vertical angles. So I will say that angle JLG is congruent to angle. And since I started at J, on the side I'm going to start at K. And I went to the center of the vertical angle and then down to the point. And again, my reason were the vertical angles theorem, which said vertical angles are congruent. This gives us another angle. And now if I look now, I have 3 parts of this triangle, and I can prove these 2 triangles are congruent now. So my last statement will be triangle GJL is congruent to triangle IKL. And our reason being is we have 2 pairs of angles and the side between them. So this is angle, side, angle. And we've now proven the 2 triangles are congruent. Here is a review of all 5 shortcuts. Side, 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 side angle, side, hypotenuse leg, angle, side angle, and angle, angle, side. This is on page 252 in your textbook if you want to copy it. This text, also this section talks about flow proofs. We are just going to use 2 column proofs, just like before where it talked about paragraph proofs and we did not do those. We are just doing 2 column proofs.